Okay, without further ado, let's move into the calculation portion here. Now, you want to watch for some keywords while we are doing these calculations. So let's get hopping at that. It says calculate the amount of energy needed, required, needed. That means we should get a positive value to vaporize 346 grams of water. Now that you notice they give us delta H of vaporization. This is where we're going to use dimensional analysis. When I have a double unit, a slashed unit, I like to set it up as a chemical equality, very much like 12 is a dozen type thing. So it's a chemical equality. And now we're going to do our dimensional analysis. And we have mass. We need to go mass to moles. That will be one step. And then we can go moles to kilojoules. So I've got 346 grams of water. I want to eliminate grams and go to moles. Water's 18.02 grams. Now I want to get rid of moles of water and I want to go to kilojoules. That's what this number tells me, that it's going to require, so I don't know what I was trying to do there. I was trying to get a positive and a 4, 40.79 kilojoules for every 1 mole. Okay, so our answer is a positive 783 kilojoules of energy. Now let's look at this next one. Water is cooled. So we're on a cooling curve. That's exothermic. So we expect our answer to be negative. Let's see if that happens. When we're cooling liquid and we are below the boiling point and above the freezing point, so we know we still have pure liquid. It doesn't hurt to graph it out. Sometimes I'll do that. I'll go up, over, up, over, up. Those are my 5 segments. And then I kind of mark on my segments where I am. So I'm going from here, which is below the boiling point, to here. That helps me know that it's only one step. So I'm going to use MCAT. So Q is equal to MCAT. It's mass, but because of grams here, I have to convert that kilograms to grams. I'm going to use the heat capacity of water. These aren't things you memorize. These are numbers that are given to you. Now remember, it's always T final minus T initial. So I have 32.3 minus 98.6. You'll see if you set that mathematics up correctly, our sign comes out naturally. And I want you to double check my math for me, my algebra, 2.9 times 10 to the 5th. Now, notice the difference here. I had kilojoules above, but this gives me joules. Be really careful. If you have to add 2 steps together, you would have to convert one of these in order to add them together. Okay, let's take a look at the next one. This time it asks us to draw the graph sketch out a heating curve, cooling curve for bromine and label the axes. So we need our y-axis, we need our x-axis. This is kind of not much room, but we'll see how we go here. Remember, we can heat a solid, we can vaporize or melt a solid, We can heat a liquid, we can vaporize the liquid, we can heat a gas. So there's always 5 segments. This is heat. So this axis is heat. Sometimes people will put time that a set kilojoules is added. So it might be like you're adding 2 kilojoules every minute, and you put down this takes 10 minutes. So you could figure out your kilojoules. And this is temperature. Now it tells me my boiling point. You don't just label the boiling point, you have to put the number there. Oh my gosh, Dina. Oh, I did not want to do that. I so did not want to do that. Let's start fresh. 1, 2, 3, 4, 5 axes. Now, you got to write in your melting point, which is -7, and your boiling point, that's the plateau up here, which is 59. Okay, right here. Right? So, calculate the energy when 125 grams, that's the mass, is changed from 55 degrees Celsius, so we're right here at 55 degrees Celsius, to -7. But it says it's still the liquid. So we're on the liquid side of this. So we're still at one step. It's an MCAT. So Q is equal to, we got to get that in grams, 25000. We're given the heat capacity of the liquid is 0.23. Our temperature is -7, final minus initial, 55. And our answer to this one is minus 1.78 times 10 to the 6th joules. Now, the next step asks us to determine the energy when it's frozen at 7. So it's just asking us this line segment up here. And so we have delta H of fusion. And so we're going to start with our 125,000. We've got to convert that to grams. This is on a per mole basis. So I'm going to use mass to moles, use molar mass. So I'm going to get rid of grams of bromine. I'm going to go to moles of bromine. And it's 159.81. Now, I'm going to use that delta H of fusion as a conversion factor. Moles of bromine in the denominator, 1057 kilojoules per 1 mole. Now, bear in mind, this is what gets a little tricky here, okay, is what's my sign? And so if you do the algebra here, we get 8270 kilojoules. The question is it positive or negative? Well, when we're freezing, we're forming. Now it takes to break, freeze to form. Takes energy to break forces of attraction, bonds or intermolecular forces, and it freeze to form. So you can put a negative there because we're forming intermolecular forces of attraction, okay? And then that's going to release heat. Now, 7 up above, I'm going to do up here. So I'm going to do example 7 up here so I don't have to scroll up the page. Now it asks us, what's my total? We had 2 steps here. Well, my total of those 2 steps is simply the sum of the 2. Make sure they're the same units. This one's kilojoules, this one's joules. And so when I add them together, I have to have them be the same units. And I happen to have done joules, so I've got 178,000 joules plus a negative, and they should be the same sign, okay? Because you're either going up where they're all positive or down and they're all negative. So negative 8271234 joules, and this ended up being minus 1.005 times 10 to the 7th joules. So again, if you would please, double check my algebra on that, I would really appreciate it. Okay, so we will take on from here. We'll do some more examples of this. So until then, this is, or I'll at least give you answers so you can check them out yourself. This is signing off.